Okay, so now we have this one. I'm going to choose the side with the fraction. It seems slightly more complicated. And because the fraction is not adding, we're not adding two fractions, we're going to need a common denominator. I do notice that the bottom has an addition and subtraction, which usually is a hint for a conjugate. So I want to go back and try to find out, here, this is example 13, which one also had a conjugate. Okay, so example 9, we had a 1 minus sine squared, and we had a conjugate, which is 1 plus sine. And notice at the top, when I multiplied, I didn't multiply the cosine. I left them separate. And that was just a helpful way because I knew I wanted a 1 plus sine at the end, so why would I multiply the cosine? So I think I want to do that for mine as well, number 13. Let's go to it. So here we have this one, 1 minus cosine. Now, I said before that I didn't want to multiply that numerator in because I saw this on the other side. I don't see it here. So I might be wrong in this case. Okay, so maybe I'll write it down to give myself a little more room here. So sine of x over 1 minus cos. And I will multiply by the conjugate, so 1 plus cos. And I'm going to try to do this, like I said, not multiply the top out. I'm just going to leave the top as sine x and bracket 1 plus cos. I don't know if that's going to help me or stop me. I don't know. We're just going to have to see. And on the bottom, I'm hoping that you'll get really good at this where we know it's going to be a 1, that the coses will cancel out, and again, a negative cos squared, which will then turn to a sine squared with an obvious substitution. So 1 times 1, 1 times cos, and negative cos, so positive cos x, negative cos x, and then a negative cos squared. Make this fraction a bit bigger here. And then, of course, the two cosines, one's positive, one's negative, they can cancel. So I have sine of x on top. I could have multiplied these through, but I'm not doing it yet. And on the bottom, I have a 1 minus cos squared of x. Now I know with an obvious substitution that will become a sine squared, which actually will work out quite nicely because I have a sine on top as well. So because these things are being multiplied, this and this and this, everything's being multiplied here, I can cancel out some signs. So 1 on top can cancel with one of the ones that are on the bottom. So it looks like I've got a 1 plus cos x on top, and then a sine x on the bottom. Now this, as if this is not difficult enough, we had something similar before where we have to separate this. If I look on the other side, it's two things that are separated. They're completely separated with a plus sign. And that's not what I currently have down here. I just have a fraction. It's a single fraction. Yeah, I realize that they're separated on top, but it's actually still a single fraction. So one of the things we can do is we can say, well, we're going to go this plus this. We've done that before already. So I'm going to have a 1 plus sign. That's that. Plus a cos of x over sine of x. So, sorry, not 1, but 1 over sine of x plus cos of x over sine of x. And the way you know that would work together, is that if these already have a common denominator, so if you were to work backwards, they already have a denominator of sine x, so that's your bottom, and then the tops would just be plus, it would be added, so 1 plus cos. It would turn right back into what we have previously. Now 1 over sine is cosecant. Cos over sine is cotangent. And is that what we have on the other side? This is a long one. Cosecant, cotangent. Yes. So the left side equals the right side. Okay. So now I take a look at this. I can kind of see, well, first I'll show you one thing. What we just did, we could do that same thing here. Whenever there's an addition or subtraction on top but not the bottom, you could separate. In this one, we could not do because the separation, the plus or minus sign, has to be on top. So this would be secant over sine squared, and then 1 over sine squared. Now, that doesn't actually turn into anything, but it is worth noting that that is something you could do. That is a similar trick. But I have to think about what it is that I could do. Which side should I choose? Because they both look equally as absurd. So I think maybe what I'll do is I'll start here. I actually don't know, but I'm going to try the left side. Only because 1 minus cos squared, I can think of the conjugate, which is 1 plus cos squared. The conjugate for this too is going to be secant squared minus 1, but I like to just deal with the cosine and not the secant. And we'll just see what happens. So I'm going to leave a little bit of room here. So I got secant x over 1 minus cos x. And then I can multiply this by 1 minus cos x and 1 minus cos x. Again, with the top, I'm not going to multiply it through. I'm just going to leave it separate. Why? Just because I don't actually know if I need to. We're just going to give it a shot. We can always multiply it through later. And the bottom here, again, I'm hoping that we get really good at this, is just going to be a 1 minus cos squared, which will then turn to a sine squared. So we're going to go 1 times 1 is 1 minus cos. Oh, it needs to be a plus. My bad. So I'm going to make this a plus. I don't know why I didn't do that, but this is a plus and a plus, which means this is a plus. And then I'm going to get a 1 plus cos x, and then a minus cos x. So 1 plus cos x minus cos x minus cos squared of x. And then those coses can cancel out. So I have secant of x 1 plus cos x all over 1 minus cos squared. Now, I know that that's going to be a sine squared. So I'm going to have secant of x 1 plus cos x all over a sine squared. This is a obvious substitution. So where are we so far? Is anything looking like the right side? Wow, very, very little. Like the sine squared on the bottom, that's kind of nice. We're matching there. But then I've got this secant x. Doesn't seem like it kind of works. So let's do what I said I wasn't going to do, and let's try multiplying it through. Secant x times 1 is just secant x. And secant x times cos x is secant x cos x. All over sine squared. Now, I can see here secant and secant. I can turn these into sine and cos. Like the very first rule is, or informal rule, is turn things to sine and cos. If I'm looking here, I've got a sine squared on the bottom, so that should match. Just trying to zoom out enough here. Yeah, I got a sine squared on the bottom. I got a secant x, so it's only the 1. I'm just missing the 1. But I can look here at secant and cos, and this is just 1. Because secant is 1 over cos. Cos is obviously just cos. And the top and bottom can cancel out, leaving you with just the 1. So this actually is indeed the answer. So we have a secant x. I'm not going to change that to sine and cos. But the secant I'm going to write as 1 over cos. And of course there's still this original cos here. Over sine squared. And those can cancel, leaving us with just a 1. So, which is exactly what we want. So left side equals right side. Let's go to the next one. Okay, so this also has conjugates of each other, and so I kind of want to do that. I just don't know which side to choose. Do I multiply this side by 1 plus sign, or do I multiply this side by 1 minus sign? Part of me wants to deal with this side only because there's no secant. So I'm going to try the right side. I could regret it. Let's take a look here. So I'm going to leave myself some room. 1 plus sine x over cos cubed. That's strange. And I'm going to multiply by 1 minus the conjugate. Conjugates don't always just have to be on the bottom. They can be on the top. So this might be the first time that I've ever done that. So 1, negative sign, positive sign, and negative sign squared. So 1, negative sign, positive sign, negative sign squared. And on the bottom, like usual, I'm not going to expand it out or multiply it. I'm just going to leave it right now. I can always do it later like I had to in the last one. So these are gone, and I have a 1 minus sine squared. Now 1 minus sine squared is an obvious substitution. It will be a cos squared, which works really nicely with me not multiplying this out, because I've got 2 coses on top and 3 on bottom. So I can cancel all of that, and 2 of those and 2 on the bottom, leaving me with just a 1. So this is really just 1 over cos of x and 1 minus sine of x. Now, is that what I have? No, I have a secant. Now, secant is just 1 over cos. And I do have a 1 over cos. It's right here, 1 over cos. It just looks kind of weird. So maybe what I'll do is I'll separate these to a 1 over cos and a 1 over 1 minus sine x. And they're both being multiplied. This step is not really needed, but it is kind of nice to see that by the way, I can do this because this is technically multiplying in there, not adding. If it was an addition, I couldn't separate it into 2 fractions, but because it's multiplying, I can. The multiplication just stays there. So 1 over cos turns into secant, and then there's a 1 over 1 minus sine x, and the secant can just go on top there. Which I believe is secant and 1 minus sine. Yes, it is. So my left side equals my right side. Perfect.